In the last video, many of you pointed out the difference in the growth rings between the new and the old growth 2x4s. Of course, this loss of density impacts the quality of the lumber and potentially the framing of new houses. But to what degree and why is the new growth losing its density? I reviewed the literature and found academic studies that quantified the change in strength over the years. Nowadays, most of the wood comes from plantation forests with vastly different rotation cycles. Douglas fir, for example, is usually harvested at around 40 years of age when grown in a suitable environment. The main reason for this is that the landowners do not want to wait an additional 20 to 30 years before realizing their profits. And secondly, most mills today are designed to handle smaller logs of at most 75 centimeters in diameter, or about 30 inches. You can see the effects of the small diameter logs by looking at a stack of 2x4s, or any other dimension for that matter. A very large portion of them are sawn from the region near the pith of the log. The problem with this is that softwood trees tend to grow much faster in the first 10 to 20 years of their life, producing wide growth rings with a high portion of low-density earlywood. After the first 20 years, the growth drops down to a somewhat constant and much slower rate, dominated by high-density latewood. For an old-growth log with say 100 growth rings, most of the wood would be slowly grown dense wood, resulting in high-quality lumber, with only a few boards converted from the center of the log. The new growth lumber, as discussed earlier, is of much smaller diameter, mostly dominated by juvenile, low-density wood, which explains why most of the 2x4s look the way they do today. But the more important question is, how does the growth rate affect the mechanical properties of the lumber? Before I answer that, I would like you to consider subscribing to the channel. That's the easiest and cheapest way to help me produce more content. This video alone took more than 100 hours of research plus animation work. Also, I will make all the academic papers cited in this video with all my notes available to download for free in the description of the video. A study at the University of British Columbia in 1995 took over 400 small samples from different locations from the trunks of western hemlock trees. The age of each sample could be determined based on how far away from the center of the log the sample was taken from. In other words, which growth rings it consisted of. First, the density of each sample was determined, and an average value was computed. As expected, for the first 15 years, the density kept decreasing. Once the tree started to produce more latewood, the density started to increase. At around 26 years, it reached the average density of an old-growth tree. The strength, on the other hand, did not follow the same pattern. Instead, it continuously increased for almost the entire life of the tree, and it only reached the average strength of an old-growth tree after 70 years. This confirms without doubt that on average, the new 2x4s are probably 10 to 20% weaker than the average old-growth piece of wood. Occasionally, there would be a high-quality board, but it would be much harder to find in a stack full of 2x4s sawn from 40-year-old trees. To make things worse, we have not accounted for any warping effects, which I left for another video. But, spoiler alert, they are also worse in juvenile wood. Keep in mind that there is also a natural variation between species, so this comparison by no means is exhaustive, but it paints a generic picture of the direction in which the dimensional lumber has gone. I'm not sure to what extent this affects the framing and the sturdiness of new houses. I wonder whether this was a reason why the stud spacing was reduced to 16 inches compared to the 24 inches often seen in older homes. I would love to hear from some of the more experienced people in the audience that have had exposure to both new and old-growth dimensional lumber. But just to be clear, I do not advocate for cutting of old-growth forests. I'm just simply stating some of the facts. Another interesting factor that changes the whole dynamic is the midlife boost in growth observed across many plantations. This is not a new thing. A study from 1974 from Washington University looked at an experimental forest plot of Douglas fir trees grown between 1930 and 1960 and measured the width of their growth rings. They noticed something incredibly interesting. After about 15 years, the trees in this plot experienced a massive boost in their growth rate, which lasted for about 5 years before returning to slower growth again. This period of fast growth of course impacts the quality of the wood at the expense of producing larger volumes. What do you think the cause of this boost in growth rate could be? Give your theory in the comment section. I will reveal the reason and explain this phenomenon in part 2 of this video. make sure to subscribe and click the bell icon so you don't miss out. For part 3 of this series, I'm looking into testing new and old 2x4s with my own hydraulic press. If any of you have access to old growth 2x4s, I would love to purchase some from you so that I can test their strength and give you an overview of my findings. Thanks for watching and stay tuned.